everyone. In this video, let us study about mixed random variable. Mixed random variable, as the name says, it contains the features of both continuous and discrete random variables. It's a sum of continuous functions and the staircase function. Continuous function is represented by p of x and discrete function is represented by p of x. Let us discuss some real-time examples for mixed random variables. If you want to submit an assignment to your professor, you visit the professor, just submit, there is nobody else submitting the assignment. You just submit the assignment and walk out of his room. Probability is 1 by 3. Here you can observe that even the value of x equal to 0, probability exists, which is a discrete function. But when you go to the professor, there may be a chance there is a queue for submitting the assignment. You have to wait in the queue, submit the assignment and walk out of the room. This can be modeled by an exponential. This is going to be a continuous function. So therefore, the PDF, probability density function, can be modeled as a discrete component plus the continuous component. Second example is daily rainfall measured in inches. There may be a day when there is no rain at all. In such cases, there is going to be some probability. So probability of x equal to 0 will be there. This can be modeled as a discrete component. And later, there are days when there are rains which can be measured in inches. It can be modeled as an exponential. Example number 3, lifetime of a bulb. Go to a shop, purchase a bulb, come back and put it in the socket. It may not work at all. In such cases, P of x equal to 0, it is greater than 0, which can be modeled as a discrete component, discrete function. And if the bought bulb is healthy, then it may light the room for a certain period of time, which can be modeled as continuous function. Let us take some examples. Let x be a continuous random variable with the following PDF. Fx of x is equal to 2x for x value varying between 0 to 1. 0 otherwise. Y is equal to g of x, that is equal to x for all values of x between 0 to half, and it is half for x value greater than half. We need to find the CDF of y. Since it is a mixed random variable, y is a mixed random variable, so the CDF can be written as sum of a continuous function c of y and the staircase function d of y. Rx is given as 0 to 1. X value can take varies anywhere between 0 to 1. For all x belonging to 0 to 1, g of x is defined as the values varies from 0 to half. Since y is equal to g of x, you can write ry is equal to 0 to half. CDF for y less than 0, it is 0. CDF for y greater than half, its value is equal to 1. Let us first find out the continuous function c of y for y value varying between 0 to half. C, probability of y less than or equal to y is the integral of 2x dx, that is equal to y square. Now at y is equal to half, fy of y is equal to half square, that gives us 1 by 4. Therefore, we can define c of y is 0 for y less than 0. It is y square between 0 to half, it is 1 by 4 x half. So when we plot it, this is y, this is fy of y component, c of y. So it is 0 and this x half, its value is going to be 1 by 4. Let us find d of y. There is a discontinuity at y is equal to half. At y is equal to half, p value, probability of x greater than half, it is d of y is the integral of 2x dx between half to 1. When we simplify this, we get it as 3 by 4. So d of y is 3 by 4 for y greater than or equal to half and 0 otherwise. So there is going to be a big jump here. That value is equal to 3 by 4. So fy of y is the sum of p of y plus d of y. So we get that CDF fy of y is 0 for y less than 0, y square for all values of y between 0 to half, and it is 1 for y greater than or equal to half. Let us take the second example where x is a random variable whose CDF is defined as fx of x is equal to 0 for x less than 0. It is half plus x by 2 for all values of x between 0 to 1, and it is 1 for x value greater than or equal to 1. We need to find the PDF of x. And if you look at here, when we plot the CDF, it is 0 for all values less than 0. Between 0 to 1, it is a straight line equation having an intercept of half and slope of half. So x equal to 1, it is going to be half plus half. It is going to have value 1. Now for all values of x greater than or equal to 1, it is 1. We need to find the PDF of x. Now if you look at here in this graph, you can understand that there is a discontinuity at x equal to 0. It suddenly jumps from 0 to half. So usually we represent it by a step function. And later on you can observe that it is continuous in nature. So therefore it is a mixed random variable. In order to get the PDF, we need to differentiate. When we differentiate a step function, we are going to get an impulse function having the value half into delta of x. When we differentiate a equation, straight line equation having a slope of half into x, we are going to get a constant value that is equal to half. And later on, it remains constant. When we differentiate this, we are going to get it as 0. So therefore, fx of x can be written as half delta of x plus half all the values of x varying between 0 to 1. Let us take the third example. CDF of a random variable x is shown in the figure. We need to write the equation fx of x. Now if you observe here, for all values of x less than 0 is 0. Between 0 to 2 is a straight line equation having intercept 0, and the slope here m1 is equal to 0.4 divided by 2, that is equal to 0.2. Then at x equal to 2, you can observe it suddenly increases from a 0.4 to 0.6. That means at x equal to 2, you have a step function of having a magnitude 0.2. Then here, once again you have a straight line equation between 2 to 3, whose slope is defined as m2, 1 minus 0.6, 3 minus 2, that gives you 0.4. So therefore, you have here between 2 to 3 integration 0.4 dx. Sum of all these should give us 1. Let us solve two problems under mixed random variable. First problem, CDF of random variable x is given here. For all values of x less than 0, it is 0. And it is 7x by 30 plus 3 by 10 for the value of x varying between 0 to 3. And it is 1 for all values of x greater than or equal to 3. We need to find the PDF corresponding to this PDF. By differentiating the CDF function, we are going to get the PDF function. So let us try to because differentiation of 0 is 0, differentiation of a constant is 0. So let us try to differentiate the equation between 0 to 3. When we differentiate it with respect to x, we get this as 7 by 30, and this is 3 by 10 delta of x, which is an impulse. Or you can write it in terms of step function. It is u of x minus u of x minus b multiplied by 7 by 30 plus 3 by 10 delta of x. Let us take the second problem. Here, a PDF of a random variable is given to us in the form of an equation c into delta of x minus 1 plus 0.13 between x value between 0 to 4, 0 otherwise. We need to find the value of c, and also we need to find the CDF. By integrating the PDF function, we can get the CDF, and that should be equal to 1. Let us integrate this between the limit minus infinity to infinity, the PDF function c delta of x minus 1 dx plus integration between 0 to 4, 0.13 dx. This should be equal to 1. When we simplify this equation, we get the value of c is equal to 0.48. Once we get the value of 0.48, we can write the CDF function because it is c is 0.48. The integration of delta function gives us a step function, and this is 0.13 into x. Thank you. Next video will be on expectations, variance